I'm Doc Antle, and let's talk about linear equations. As you can see, there are three ways to represent linear equations. We have slope-intercept form, which is y equals mx plus b. That's what you're most familiar with, where our m is our slope and our b is our y-intercept. That's where the line crosses the y-axis. Our point-slope form is y minus y1 equals m times x minus x1. And x1, y1 is a point on the line. Any point on the line will work. And our standard form is ax plus by equals c. And we have some rules. A, b, and c are all integers. A, b, and c cannot have a greatest common factor with all three of them. And a must be positive. Up here on the board, I have a point. It is 2,11, and I have a slope, which is 3/2. And I'm going to use this information and my knowledge from yesterday from Ms. Reeve-Exotic to learn how to rewrite this equation in all three forms. So I see a point and a slope, so it makes sense for me to start in point-slope form. So y minus y1 equals m times x minus x1. y1 is my y value, it's 11. So y minus 11 equals m is slope, which is 3/2, times x minus x1 is the number 2. This is point-slope form. So y minus 11 equals 3/2 times x minus 2. This is my point-slope form. And now from point-slope form, I think the easiest thing for me to transition into would be slope-intercept form. So from here, I'm remembering my multi-step equation rules. My goal is to get y by itself. So we are going to solve this equation for y. So the first thing I'm going to do is distribute this 3/2 to everything in here. So I'll distribute my 3/2 to the x, and I'll distribute my 3/2 to the 2. So I have y minus 11 equals 3/2x minus 3. Now if I want this y by itself, I'm going to add 11 to both sides, because that is my inverse operation. So I end up with y equals 3/2x plus 8. And that right there is my point-slope form. So my point-slope form is y equals 3/2x plus 8. Now from here, I'm going to go into standard form. Now in my standard form, the part that's by itself is the constant. It's the number that is not connected to one of my variables. In this case, my number that's not connected is this 8. So if I want this 8 by itself, I'm going to subtract anything that is not the 8. So I'm going to subtract 3/2x minus 3/2x minus 3/2x, and I'm going to just rewrite over here. So I end up with negative 3/2x plus y equals 8. But I need to make sure that I'm following my rules. A, b, and c are integers. 3/2 is not an integer. So what I'm going to do is multiply both sides by 2. And the reason I'm multiplying by 2 is because we have a 2 on the bottom of this equation. So I'm going to distribute my 2 to everything involved. So I end up with negative 3x plus 2y equals 16. But I'm still breaking a rule here. Rule number 3 says a must be positive. So again, I'm going to multiply the whole thing by -1. Multiply by -1, multiply by -1, and I'm doing that so that my a value can be positive. I'll distribute my negative 1 to everything involved, so I end up with 3x minus 2y equals negative 16. And this is my standard form. So I have 3x minus 2y equals negative 16. Now if I wanted to get from here back into my slope-intercept form, I want to solve for y. I want to get y all by itself. So what I would do to get y by itself is first I would subtract anything that is not y. In this case, it's this 3x. So I'll subtract 3x from both sides. I end up with negative 2y equals negative 3x minus 16. Now I want this y by itself, so I'm going to divide by negative 2. Divide by negative 2. And I end up with y equals 3 over 2x plus 8, which is my slope-intercept form over here. Now, if I wanted to take this slope-intercept form and I wanted to find a point, what I could do is I could plug any number in. So I'll use this one that we had just so I can show you that it works. So for example, I would plug 2 in for my x value so that it would bring me out a y value. So y equals 3 over 2 times my x value is 2 plus 8. Y equals 3 plus 8, which means that my y is 11. So I plugged in an x value, it was 2. And I got out a y value, and it was 11. So you can use any form of this equation to plug in an x value and get out a y value for any point on this line. I also want to show you how to find where the line will cross the y-axis and where it will cross the x-axis. But give me a minute to make some space. So you can find the x and y intercept with any version of this equation. I happen to be using standard form because I think that's the easiest way to find the x and y intercepts. So your y-intercept is where your graph crosses the y-axis. So for example, here's my graph, right? And here's my line. This right here where it crosses the y-axis is my y-intercept. And this right here where it crosses my x-axis is my x-intercept. Now my x-intercept is where my y value is 0. In other words, I haven't gone up or down any on my x-intercept. And I haven't gone left or right any on my y-intercept. So if I want to find my y-intercept, I'll plug in a 0 for x. So if I'm looking for my y-intercept, I'll plug in a 0 for x. So 3 times 0 minus 2y equals negative 16. I'll divide, 3 times 0 is 0, so they cancel out. So I end up with negative 2y equals negative 16. I'll divide by negative 2 to get the y by itself. And I end up with y equals 8, positive 8. And I can double check my answer by looking at my slope-intercept form, because my y-intercept is this constant value, it's 8, we're correct. I can also look for my x-intercept by plugging in a 0 for y. So 3x minus 2 times 0 equals negative 16. 2 times 0 is 0, so I end up with just 3x equals negative 16. I'm going to divide both sides by 3. And I end up with x equals, you could actually leave it as a fraction here, this negative 16 over 3, or you could divide 3. And that would give you about 5.3 repeating. So x equals negative 5.3 repeating. And it's a negative 5 because this is a negative 16, and a negative divided by a positive is a negative. So my x-intercept is negative 5.3 repeating. My y-intercept is 8. And that is how you can convert between the different forms of the equations, or you could find a point on the line, including your x-intercept and your y-intercept.